Hello friends, I am Viddya Patil, Assistant Professor, Department of Mechanical Engineering in Sharad Institute of Technology Polytechnic, Yadra. Today we are going to start our first unit of the subject Power Engineering and Refrigeration, that is Internal Combustion Engine. Okay, so today in this session we are going to cover the introductory part of IC engine, classification of IC engine, engine components, engine terminology, and working of four-stroke engines. From that, working of four-stroke petrol engine or SI engine. Okay, we start from introduction of the IC engine. Before that, first we see what is engine. Okay, engine is a device which transforms one form of energy into another form. Normally, most of the engines convert thermal energy into mechanical work, and therefore they are called heat engines. Okay, heat engine is a device which transforms the chemical energy of a fuel into thermal energy and utilizes this thermal energy to perform useful work. These heat engines can broadly classified into two categories. First is the internal combustion engines, that is called IC engines, and second is the external combustion engines that are called EC engines. Okay, in this session we will see the IC engines. Okay, IC engines, these are the internal combustion engines where the combustion of the fuel takes place inside the cylinder, okay, itself with the air induced from the atmosphere. And internal combustion engines, the chemical energy of the fuel released and raises the pressure and temperature of the products of combustion. But in external combustion engine, the combustion takes place outside the cylinder in a furnace, and the heat energy of hot products of a combustion, that is flue gases, is used directly as in case of gas turbines to develop the mechanical power. Okay. The advantages of this IC engine over EC engines are these are compact and efficient, and also they have low weight to power ratio. Also they need less maintenance cost, and hence operating cost also low. And they do not need auxiliary equipment like furnace and heat transfer equipments which are required in external combustion engines. They are suitable for mobile applications. Okay, now we see the classification of IC engine. The classification of IC engine is classified based on the various systems. Okay, first is based on the number of strokes per cycle. There are two types, that is four-stroke engine and two-stroke engine. In four-stroke engine, in which one cycle is completed in 4 strokes of the piston into 2 revolutions of the crankshaft. But in two-stroke engine, the cycle is completed in 2 strokes of the piston in 1 revolution of the crankshaft. That is two-stroke engine. Okay. Next type is based on the thermodynamic cycle. There are so many thermodynamic cycles, but here 3 are mentioned here. That is first type constant volume combustion cycle, that is Otto cycle. Second is constant pressure combustion cycle, that is diesel cycle. And third is partly at a constant volume and partly at a constant pressure combustion cycle, that is also called dual combustion cycle. Okay, next is based on the number of cylinders. Okay, that is there are 2 types, that is single cylinder engine and multi-cylinder engine. Okay, next is based on the ignition system, that is spark ignition system and compression ignition system. Spark ignition systems are also called SI engines, and compression ignition systems engines are called CI engines. In spark ignition engine, petrol engines are use the spark ignition system for the igniting the compressed charge, and in diesel engine utilizes the high temperature raise due to the high compression ratio of the cylinder. Okay, these are the 2 types. Next type is based on arrangement of cylinders. There are 5 types, that is inline engine, V engine, radial engine, opposed cylinder engine and opposed piston engine. Here in this figure, that is engine classification cylinder configuration is shown in this figure. Here we see that first is the inline engine. In inline engine, in this all the cylinders are arranged with their axes parallel and transmit the power to the single crankshaft. Here we can see in inline engine. Again in second, that is V engines. In V engine also we see here in V engine, these engines contain two banks of the cylinder connected to same crank and crankshaft and their axes are inclined to each other. Here we can see V engine. Next is the radial engine. In radial engine we see here there is in these cylinders are arranged radially and are connected to single crankshaft. Here we can see the cylinders are arranged radially and are connected to single crankshaft. Next is opposed cylinder engine. In opposed cylinder engine we can see here opposed cylinder engine, that is horizontally opposed. Okay, in this engine there are two cylinder blanks which are located in the same plane on opposite side of the crankshaft, and it can be visualized as two inline engine arrangement, that is in 180 degree apart, and the connecting rods of the two cylinders are connected to a single crank. It provides a well balanced engine. And last is opposed piston engine. In opposed piston engine we see here in this engine a single cylinder houses two pistons, each of which drives the separate crankshaft as shown in figure, and it also well balanced engine. And the advantage of such an engine is that is required no cylinder head. Okay, this is based on arrangement of cylinder. Next is based on cooling system, that is water cooled and air cooled. Okay, next is based on fuels used, that is petrol engine, diesel engine, gas engine and biofuel engine. Okay, in biofuel engines are used the main fuel as a gas and the liquid fuel is used for the starting purpose. Okay, next is based on the fuel supply system, that is carburetor engines, solid injection engines and air injection engines. In carburetor engines, the mixture of petrol and air from the carburetor is supplied to the engine cylinder. And in solid injection engine, the diesel engine, in case of diesel engines, the fuel is injected with the help of a fuel pump. And in air injection engines, in certain diesel engines also, the fuel is injected in the cylinder with the help of compressed air. And last classification is based on the lubrication system, that is wet sump lubrication, dry sump lubrication and pressure lubrication. Next we see the engine components. Here in figure 1 we see cross section of the spark ignition engine. Okay, here there are various components, that is spark plugs, inlet exhaust valve, inlet manifold, exhaust manifold, that is cylinder, piston, gudgeon pin, that is connectant rod, crankpiece, crankcase, sump, crankshaft and cylinder block. Now we see one by one the component of the engine component and their function. First we start from the spark plug. Here is a spark plug. Okay, it is a component to initiate the combustion process in spark ignition engines, and it is usually located in the cylinder head. Okay, next is a inlet and exhaust valve. These are the inlet and exhaust valves. These valves are commonly mushroom shaped poppet type, and they are provided either on the cylinder head or on the side of the cylinder for regulating the charge coming into the air. It regulates the charge coming into the air, coming into the cylinder, that is from inlet valve, and the discharging the product of combustion, that is exhaust valve. Here the inlet valve and here the exhaust valve. Okay, next is a inlet manifold and outlet manifold, exhaust manifold. Okay, here is the inlet manifold and this is exhaust manifold. Inlet manifold is the pipe which connects the intake system to the inlet valve of the engine and through which air or air-fuel mixture is drawn into the cylinder. That is called inlet manifold. And exhaust manifold is the pipe which connects the exhaust system to the exhaust valve of the engine and through which the products of the combustion escape into the atmosphere. That is called exhaust manifold. That is exhaust manifold. Here air inlet, air and fuel inlet, that is product outlet. Okay, this is next is the cylinder. Okay, here we can see cylinder. Cylinder is the space in which the piston makes the reciprocating motion. Okay, it is varying volume created in the cylinder during the operation of the engine is filled with the working fluid and it is subjected to different thermodynamic processes. Okay, the cylinder is supported in the cylinder block. Okay, next is the cylinder block. Okay, or piston. Now first we see piston. Piston is a cylindrical component fitted into a cylindrical forming the moving boundary of the combustion system and it fits perfectly into the cylinder, providing a gas tight space with the piston ring and lubricant. It forms the first link in transmitting the gas forces to the output shaft, that is piston. This is gudgeon pin. Okay, this gudgeon pin is it links the small end of the connecting rod, and the piston. That is, this is gudgeon pin. Okay, this is connecting rod. Okay, now connecting rod is the interconnects the piston and the crankshaft. Here piston and the crankshaft and transmit the gas forces from the piston to the crankshaft. The two ends of the connecting rod are called small end and big end. Small end is connected to the piston. This is small end is connected to piston and big end, this is big end, is connected to the crankshaft by crank pin. Here there is a crank pin. Okay. Next is the crankshaft. This is a crankshaft. Okay, and it associated parts to control the opening and closing of the two valves. Okay, next is this is sump. Sump is used for the lubrication system. This is all about engine components. Okay, next now we see the engine terminology. In engine terminology, first we see the cylinder bore. That is, it is mentioned here, cylinder bore, that is the nominal inner diameter of the working cylinder is called as the cylinder bore and is designed by the letter small d and it is expressed in millimeters, that is mm. Second is the piston area. It is denoted by A, capital A. This is the area of a circle of diameter that equals to the cylinder bore. Okay, is called the piston area and is designated by the letter A and is also expressed in square centimeters. Third is the stroke. It is denoted by capital L. This is the nominal distance through which the working piston moves between two successive reversals, okay, of its direction of motion is called stroke and it is designated by the letter L and expressed in mm. Okay, next is the stroke to bore ratio, that is length to diameter ratio, that is length that is stroke and d, small d is the cylinder bore diameter. Okay, this is important parameter to classify the size of the engine. If this cylinder bore diameter is less than the stroke, then that engine is called undersquare engine. If the diameter is equal to the stroke, then it is called square engine, and if the diameter is greater than the stroke length, then it is called over square engine. Okay, next is the dead center. Okay, dead center is the position of the working piston and the moving parts which are mechanically connected to it, and the movement which direction of the piston motion is reversed at the either end of the stroke is called dead center. There are two dead centers, top dead center and bottom dead center. Here in this figure we can see, in first figure there is a top dead and second is the bottom dead center. Here in top dead center, the piston is farthest from the crankshaft. It is no near to the crankshaft, and it is designed by, it is also called top dead center, that is TDC. This is piston is farthest from the crankshaft. But in bottom dead center, piston is very nearest to the crankshaft, so it is also called bottom dead center, that is BDC. Here we can also see their top dead center, their bottom dead center, and length between them, that is stroke. Okay, and here also we can see the clearance volume. When the piston is very farthest from the crankshaft, there the volume created, that is clearance volume. Okay, and it is bore diameter, that is D. Okay, here displacement or swept volume. Here we see that is denoted by Vs, that is nominal volume swept by the working piston when the traveling from one dead center to other is called a displacement volume. Okay, and it is expressed in terms of cubic centimeter, that is cc, and given by swept volume Vs is equal to area into length. The area of the piston, that is pi by 4 d square into length, that is stroke. Next is the cubic capacity of engine or engine capacity, that is the displacement of volume of cylinder. If we multiply it by that by the number of cylinders in the engine, then we can got the cubic capacity or engine capacity, and it is denoted by cubic capacity, and it is calculated by, if we consider K is the number of cylinders, then Vs into K, that is displacement volume into number of cylinders, that is cubic capacity. Okay, next is the clearance volume, that is denoted by Vc, the nominal volume of the combustion chamber above the piston when it is at the top dead center, that is clearance volume. Okay, in last figure we see here, that is clearance volume when piston is at top dead center. Okay, that is clearance volume. And second, last is the compression ratio. It is denoted by small r, that is the ratio of total cylinder volume when the piston is at the bottom dead center. Here in this figure we can see there is a compression ratio is equal to 6, that is when the cylinder piston is at bottom dead center, there is created the clearance volume compression ratio, that is r. Okay, and compression ratio R is equal to 1 plus Vs divided by Vc. Now we see the working of 4-stroke engine. Okay, in a 4-stroke engine we generally know there are 4 strokes or 4 cycle of operations for the ideal SI engine. Okay, that are suction stroke or intake stroke, second is a compression stroke, third is expansion or power stroke where work done is obtained, and last is the exhaust stroke. Here in figure number 3 we see the 4 figures A, B, C, D where working principle of 4-stroke SI engine as shown, where in first figure there is a intake, in second there is a compression, third there is a expansion, and fourth there is a exhaust. And here ideal pressure versus volume diagram, that is PV diagram of 4-stroke SI engine is shown here, where Vc and Vs, that is swept volume and volumes are shown here. Okay, now we see one by one cycle, that is first is the suction or intake stroke. Here in this figure we see suction stroke, that is from 0 to 1. Here from 0 to 1, that is suction stroke. Okay, starts when the suction stroke starts when the piston is at top dead center and it moves downwards. Okay, that time inlet valves are open and opens instantaneously, and at that time exhaust valve closed. Okay, and due to this suction, there is a motion of the piston towards the bottom dead center. The charge consisting of air fuel mixture is drawn into the cylinder, and when the piston reaches the bottom dead center, the suction stroke ends and the inlet valve closes instantaneously. That means in suction stroke, inlet valve open, exhaust valve close, and piston moves from top dead center to bottom dead center, and because of this movement of piston, air fuel mixture drawn into the cylinder. That is suction stroke. Next is the compression stroke. In compression stroke, the charge which is come from the suction stroke is compressed by the return stroke of the piston from 1 to 2. Okay, and during this stroke, both inlet and exhaust valves are closed position, and the mixture which fills the entire cylinder of volume is now compressed into the clearance volume. Okay, and at the end of this compression stroke, mixture is ignited with the help of spark plug. Here the spark plug is located. Okay, spark plug. And in ideal engines, it is assumed that the burning takes place instantaneously when the piston is at the top dead center, and hence the burning process can be approximated as the heat addition constant volume. So during this burning process, the chemical energy of the fuel is converted into heat energy and producing a temperature rise about 2000 degrees centigrade. Okay, and the pressure at the end of this combustion process is considerably increased due to the heat release from the fuel. Here we can see both valves are closed. Okay, next is the expansion or power stroke. In this stroke, expansion or power stroke, in this stroke, the high pressure of this burnt gases forces the piston towards bottom dead center. Okay, and that time both valves are in closed position. Okay, and of the 4 strokes, only during the stroke power is produced and work done is obtained. Both pressure and temperature decreases during this expansion process. Next is the exhaust stroke. Here at the end of the expansion stroke, the exhaust valve opens instantaneously and the inlet valve remains closed. The pressure falls to atmospheric level at the part of the burnt gases escape, and the piston start moving from bottom dead center to top dead center. Here we see from 5 to 0 in PV diagram, and sweeps the burnt gases out from the cylinder almost at the atmospheric pressure. The exhaust valve closes when the piston reaches to top dead center. Here in this the figure number 4 in ideal PV diagram of the Fourstroke SI engine, we see process that is 0 to 1, that is suction stroke, where air fuel mixtures enters into the cylinder from inlet valve, and 1 to 2, that is combustion stroke, where that compresses, and because of compression the pressure and temperature increases, and again 2 to 3 there is a pressure increases, and 3 to 4, that is power stroke, where after work done is carried out in this cycle, and because of that 3 to 4 pressure and temperature again decreases, and again 5 to 0, that is exhaust stroke, where exhaust valve is opens and piston moves from bottom dead center to top dead center, and because of that exhaust gases or burnt gases escape out from the cylinder. Now we see one animation to understand the working principle of 4-stroke spark ignition engine, that is petrol engine. Here we can see there is an inlet valves, here the outlet valves, exhaust valve, there is a spark plug, and there is a piston. Here we see there is a spark plug, piston, and there is all components we can see here. Now here the starting with the first stroke, that stroke we also known as suction stroke. And here we see that during this stroke, piston moves from top dead center to bottom dead center, and inlet was open. Because of that, piston propagates the air fuel mixture is sucked in the engine cylinder, and the exhaust valve remains closed throughout the stroke. Okay. After moving into the second stroke, which known as compression stroke, the piston moves towards the top dead center. Here we see piston move towards the top dead center, and it presses the enclosed air fuel mixture drawn in the engine cylinder during the suction stroke. Okay, pressure of this mixture rises in the cylinder just before end of the stroke. The operating plug initiates the spark. Okay, operating plug which initiates the spark, which ignites the mixture, and combustion takes place. Okay, inside the cylinder. Both inlet and exhaust valves are closed during this stroke. Next stroke, that is third stroke, that is working stroke or power stroke, where work done is carried out. It is in this stroke, when the mixture is ignited by the spark plug, the gases are produced which driven the piston from top dead center to bottom dead center. Here we see piston towards top dead center to bottom dead center, and thus work is obtained. In this stroke from the engine, the other strokes, namely suction, compression, exhaust, being idle, and flywheel mounted on the top of the shaft stores the energy during this stroke and remains closed. Both